We're talking about acceleration. Acceleration. When an object is accelerating, when it's changing velocity. But velocity is a vector, and a vector has a magnitude, and also it has a direction. So if the velocity is increasing, you have accelerate, the object is accelerating. If the velocity is decreasing, then that object is accelerating too. But if the object is changing position, okay, then it's accelerating too. Questions about that? No. You remember that you can use velocity or speed, because the difference between velocity and speed is just the direction. When you look at this picture that you have here, okay, see, uniform motion, constant velocity. With a constant velocity, are you gonna be accelerating? No. Okay, remember that we can use vectors to represent this velocity. What happened over here? The magnitude of the vector, see, is increasing. So in this case, the person is accelerating. Now what happened over here? The magnitude of the vector is decreasing, so the person is accelerating, and in this case, we call that this acceleration. That happens when you apply the brakes into your car, no? Okay, you are changing the velocity, but still you are accelerating. Questions about that? No? No. Do you understand that? Yes. It wasn't that difficult, right? No. We are trying to explain the same over here using vectors. Okay, when the final velocity is bigger than the initial velocity, see, you will have a diagram like this in which the vectors are increasing, right? So acceleration is positive. When the final velocity is smaller than the initial velocity, you are going to have a diagram like this. Acceleration is negative because you were decelerating. Negative. Understand that? Mm-hmm. No complicated. And you have that over here. See? They were working with the vectors. Remember, velocity is a vector. The difference in the vectors is going to give you the acceleration. If the initial, okay, is bigger, let's say that this is the initial, and this is the final velocity, okay? So you have the final, and then from the final, you have to put the initial. That's why it's going to give you a negative acceleration when you are subtracting vectors in there, okay? Okay, don't copy. Bueno, if you want to copy, that's up to you, but you don't have to. I'm going to copy everything. Okay, now, more about acceleration. And now they are analyzing. Remember, they were looking at the magnitude just to let you know you have a negative of a positive acceleration. See, acceleration is a vector. It has a magnitude and what else? Direction. And a direction. Okay. So let's say that the car is moving all the way east. See the vectors that they are increasing, meaning that the final velocity is bigger than the initial. So acceleration is positive all the way through the east. See that? Questions about that? No. But when it's all the way around, so it's, see, begins over here, and then what happened to the ending velocity? Because it's decelerating, in the opposite direction. So you have to look at the problems and you have to analyze. Questions about that? No? Always remember that acceleration is a change in what? A variation. Remember, this is not a triangle. What is this?
Delta.
Delta is a variation in velocity over a period of time. Miramos, that's an equation. Yes, that's the equation that we're going to use to find acceleration. Acceleration. I'm saying that right. Algebraically. This is the question that we're going to use. Questions? No?
The car, you put that vector to the east because it's moving, so the bottom one would be...
You have to look at the problem. Maybe that car was moving to the north. Maybe that car was going northwest.
Okay.
It depends on the problem that you have. There's not like a general formula. You have to look at the problem. In the problem, they're going to let you know where the direction in which the car is moving. Based on that, you have to analyze. What is this? This is a graph.
Velocity versus time.
This is a graph. You're familiar with the graph. Okay. Now, is velocity versus time. Time in second. Velocity meters per second. Okay. When you have a horizontal line, what does that mean?
Constant.
The velocity is constant. The slope of the horizontal line. What is the slope of the horizontal line?
0.
Is 0. Meaning that the object is moving because you have a velocity, but it's not accelerating unless it's changing changing the position. It's not accelerating. So you have a velocity versus time graph that is a horizontal line, no acceleration. Okay? Velocity versus time. And you have a line in there. That means that the object is accelerating at a constant rate. Now, the velocity is a constant? No, okay? But it's accelerating at a constant rate, and the slope of the line, velocity versus time, is going to give you what? The acceleration. Understand what I'm saying? You want me to repeat that one more time?
So repeat it one more time.
Okay, velocity. Let me use another color.
Yeah, that's what I did.
Velocity versus time. Velocity. Okay, when you have a line, that means that the object is accelerating. Object accelerating at a constant rate. But that doesn't mean that the velocity is a constant. Okay? Means that you're going to start over here. And then during this part, your velocity is going to be 5. Okay, let me see. Let me erase this. In this part, let's say that I'm going to put 1 second over here. Your velocity is 5 meters per second, but then for the next second, your velocity is going to increase to 10 meters per second. And then during the third second, you're going to increase your velocity to 15 meters. See that you are increasing the velocity at a constant rate. Okay, that's for the acceleration. You have a line, but the velocity is not a constant. Questions about that? If you have that over here, see, when the slope is equal 0, it's not accelerating. Can I erase all of this? Se me fue. Ahora sí voy a buscar quién se me fue. Ahora sí voy a buscar quién. I'm going to stop over here. I'm going to put it on the video. Okay, so in the graph that you have over here, the objects, they are moving at different speed. but at a constant acceleration because the speed is increasing or decreasing at a constant rate. Are you gonna have a case in which the object is moving at a constant velocity and it still is accelerating? Yes. When the object is moving in a circular pathway, at every point in time, it's changing position, so it's accelerating. And yes, Luca, you know what happens when the car is accelerating? That is changing. In the case that you have here, it's changing velocity and it's changing the position. In a circular pathway, the velocity stays constant, but it's changing the position. So it's acceleration too, because the velocity vector is the one that is changing. Okay? Questions? No?
Yeah, but not on that.
Okay. Mirama, what is this? Parabola. What is this? Parabola. What are we gonna do there? Miss Ramos, right now you were explaining that if we have a straight line in a velocity versus time graph, the slope is gonna give you what? The acceleration. No? It's gonna give you the acceleration. And when you have a constant acceleration, instantaneous acceleration, and average acceleration, the same. Now, Ms. Ramos, what's gonna happen when we don't have a straight line?
That looks like an exponential curve.
It looks like an exponential
Are we about to
curve,
get destroyed?
or it looks like half of the parabola. You see this that you have over here? What they are explaining over there is that the instantaneous velocity, let me use another color, is the slope of the line the slope of the line tangent to the curve at any given point. See how that slope is changing? If you get a point and you trace a line, the slope of that line at that point is gonna be the instantaneous acceleration. Ms. Ramos, how do you do that? You don't know how to do that because you're not taking differential calculus. Let's say that function that I have over there, you don't have to know this. That this function that I have here represented, okay, can be represented with this equation, plus 3. If I find the first derivative of the function is going to be 4x, okay, plus 2. See, I'm going to be able to plug the time in there, and it's going to give me the slope at any point. So I'm going to be able to find instantaneous acceleration. But you don't need to know this. Let me erase this. The only thing that you need to know is that when you have a curve in the velocity versus time graph, instantaneous acceleration is given by this slope of the line tangent. How do you say that? Tangent.
Yeah, tangent.
Tangent to the curve in there. Okay?
So
Ay, mi Ramos, are we gonna solve problems like that? Probably. Así que get a good ruler. Let me erase all of this.
When you have a curved line.
When you have, no, a curved line, no, that's impossible. When you have a velocity versus time graph and is represented by a curve, the instantaneous acceleration, can be found by finding the slope of the line tangent to the curve at that given point. Let's say that I want to find the instantaneous acceleration after 3 seconds. Go over here, my point over there, a good ruler, and then I'm going to trace the line. And then I find the slope of this line. And that's the instantaneous acceleration. Questions? No? Mirame, what's going to happen with the average? The average acceleration, we're going to use the formula. Don't remember that? Variation in velocity over the time interval. So, average acceleration and instantaneous acceleration, when you have a curve in the velocity versus time graph, they're not the same. Now, if you have a line, average acceleration and instantaneous acceleration are the same value. You get that? Mm-hmm. Okay. Acceleration, what do you have in here? An equation. Remember that different is always final minus initial over the time interval. What's gonna happen? What's going to happen? Okay, let me put over here acceleration. Okay, acceleration. When the final velocity is bigger than the initial, what happened with the acceleration? Because the time can the difference in time be negative?
Then it's positive.
Can the difference in time be negative?
No.
No. So final velocity bigger than initial, positive acceleration, meaning that the velocity is increasing, so you are accelerating. Putting that, you put on the acceleration in the accelerator, and then you're going to Orlando. Okay, initial bigger than final, what's gonna happen? Negative. That's when you are putting your foot on the brake. You don't notice that, but your car in that moment is going in the opposite direction. Okay, questions about that?
None.
No? Now, let me see what else is positive, negative, and that's it. When you have over here the final velocity equal to the initial velocity, acceleration is equal to 0. And then you have a horizontal line in your graph, velocity versus time. Questions about that? No?